Okay, so in this video we're going to talk about how we find our axis of the solids of revolution when we actually shift the axis of rotation. So we're going to start off with talking about the disk method, where we shift it up and down, left and right, and then over here we'll talk about the washer method where you shift up and down, and this one's left and right. Okay, so to begin with, when we talk about the disk method, we have solid shapes. Okay, there won't be any holes whatsoever. So let's look at the first one. So we talk about this method where you have the rotation is 1, y is equal to negative c. So y equals negative c, that means it's going to be at the bottom, okay, it's below the x-axis. So that means because number one, when we rotate, we have to talk about which direction. So the disk method, it's always going to be vertical. If it's going to be axis, when the rotation is on the x-axis or anything that's vertical. So when we talk about this, we need to talk about the outside and inside. Okay, so in that case, this is the outer radius, my function minus c, and my inner radius is going to be this region over here. So my volume here is going to be equal to integral from, put a pi outside, and then we have from a to b, because we're integrating with respect to x. And then let's talk about the outer radius and inner radius. My outer radius is f of x and c, the distance between that. So it's going to be f of x minus c. That means f of x plus c squared minus the area underneath this. In that case, this thing is going to be 0 minus c. In that case, you get c squared dx. Okay? Now, second example is going to be this method where you have rotation is above the x-axis. It's above my curve. Okay, so again, let's go ahead and show the direction of integration, not the axis of rotation, and then because it's parallel to the x-axis, in that case it's going to be vertical as well. Okay, so my outer radius is from c all the way to my x-axis. My inner radius here is going to be from my function f of x to c. Okay, so the distance here is decreased as we go. So it's going to be c minus f of x is my inner radius, and c, my x-axis. It's not changing. So c is the distance that is on the outside. So that means my volume here is going to be the integral from, again, pi from a to b, and then my outer radius is going to be c, because this is the distance, it's never going to change. So I'm going to say c squared minus, again, c minus f. It's ever changing. So that means c minus f squared dx. Okay, I should rewrite that. Give me a sec. F of x squared dx. Okay, these are pretty standard. Okay, you just have to know which is the outer radius, which one's the inner radius. So this one here is the outer radius. This is the outer radius. And this is my inner radius. Okay, this is my inner radius. Now, when we have the shift of the axis of rotation, it's on vertical. That means it's shift left and right. So in that case, this first example, it's on the left side of the y-axis. So that means, again, axis of rotation, let's show that. And because we integrate this way, it's rotating this way, it's going to be this way. It's going to be horizontal. Okay, so my outer radius here is going to be from the distance to my function, and my inner radius is going to be from my function to the y-axis. Okay, that's not ever going to change. Again, that distance here is the inner radius, and the outer radius is blue. Okay, so that distance is changing depending on f and the distance to negative c, and this distance here is always going to be the same, because it's just a vertical line. So that means my volume here, let me erase that, x equals negative c. So my volume here is equal to pi integral from a to d. Okay, I'm purposely not doing c and d because I don't want the conflict with the c. So my outer radius is from the distance from f to negative c. So in that case, f minus c gives me f of y minus c. In that case makes it plus. Subtract my inner radius, which is 0 minus c. So in that case, it's just going to be c squared dy. Okay. Now, next one here, again, outside and inside. So it's always the outside minus the inside. Okay, next one. The disk method, when your rotation is on x equals c, where it's again on the right side of the y-axis. Okay, so that means my volume here is equal to, actually, let's set it up. It's rotating there, so let's signify that. And because it's rotating around the axis that's vertical, the cross section is going to be perpendicular to that. Okay. So that means my inner radius is from my function to c. That's my inner radius. My outer radius is going to be from, well, from the y-axis to c. So in that case, this is my outer radius. So that means my volume here is equal to pi integral from a to d. And then my outside function is always going to be the same, so it's going to be c squared minus f of y, well, c. This is the distance. C minus f of y. Oops. C minus f of y squared dy. Okay, so that's that. Again, outside and inside. This is my outside function, and this is my inside function. Okay? Hopefully that makes sense. Now, in the next one here, we're going to talk about the washer method. Okay? Same idea, but we're using the washer method. Okay? So let's go ahead and do this. So, the first example, we're rotating around y equals negative c. That means it's below the x-axis. So that means, let's go ahead and do the basics. Rotating here, and again, the cross sections are perpendicular to the axis of rotation. So it's going to be vertical. So that means we integrate with respect to x. Now, my outside function, the outside radius is my f of x and the distance to f of c. So that means that's my outside radius. My inner radius is from my bottom function to negative c. So in that case, it's up. It's my inner function, inner radius. So that means my volume here is equal to integral from a to b, pi on the outside, and my outside function f of x minus c, which makes it f of x plus c squared. Subtract from g of x minus c. Makes this plus. Okay? And that's what it is. Okay, and this is my outside function. This is my inside function. Okay? Now, for the washer method, what we have here is the axis of rotation is above the x-axis. So this is y equals c. Okay? So, as always, axis of rotation signify that the cross section is going to be perpendicular. So again, we're going to integrate with respect to x. Okay, so my outside radius is from axis of rotation to the bottom function, and my inner function is going to be from axis of rotation to my inner function. In this case, the top function on top. Okay, so that means my volume here would be, again, pi between a and b. My outside function is going to be the distance between c and g. That's my outside function. See, notice how this is going to decrease slightly, go like this. This one's going to be increasing like that. So that means my outside function is, in this case, c minus g of x squared minus c minus f of x squared dx. Okay? So again, inside and outside. This is my outside function, and this is my inside function. Okay? The reason why we do this, where we have to subtract in from this, even though it's always positive, but the purpose of doing this is to make sure that c is always above it. So that means the top number minus the small number. So this one, you always get positive inside. Okay, it's just notation-wise. Just makes it easier. Now, the next part here, we have washer method. Axis of rotation is x equals negative c, so it's vertical. So that means, again, signify that, and the cross sections are perpendicular to that, so it's going to be horizontal. That means we will be integrating with respect to y. So my outside function here is my function to the f of x, f of y to my c. That's my O. My inner function here is going to be from g of y all the way to negative c. So in that case, this is my inner function, inner radius. So that means my volume here is equal to pi from a to d, since we're integrating with respect to y. And then what we have next here is we have f of y minus c. F of y minus c. Minus c, which makes it plus. And then we have the inner radius, which is g of y minus c, which again is plus c in this case, dy. And then we have our outside function, and then we have our inside function. Okay? Now, what's your method where the axis of rotation is above the y-axis? It's on the right side. So, again, axis of rotation signify that, and cross sections are perpendicular to the axis of rotation. So that means my outer radius is from g of y to my axis of rotation, that's my outside. My inside function is going to be from f all the way to c, so that's my inside function. So that means my volume here is equal to pi integral from a to d. And then my outside function is my g of y and c, so c minus g of y. So c minus g of y squared minus c minus my f of y. C minus f of y squared dy. Okay, so that is the formulas that we have. Okay, so this is my inside, and this is my outside. Okay, so there you go. Those are the formulas. So in essence, what you get out of this is with these formulas, you just need to plug and chug. But I hope just through this video, it shows you how they come to be, how this equation is all derived. Okay, so this handout here is a summary of everything we just talked about. This is very helpful. So make sure you don't lose it. Okay, if you lose it, I have a link at the bottom of this in the description, so you guys can just go and download. Okay. In the next video, we're going to talk about a couple examples, and then that's it. Okay. See you in the next one.